Hello students, welcome to Online Maths Classroom. This is part 6 of your topic integration, and today we will take up integration by parts and we will solve exercise 7.6 based upon this concept. So let us start with it. Integration by parts. In this section we describe one more method of integration that is found quite useful in integrating product of functions. If u, v are any two differentiable functions of a single variable x, then by product rule of differentiation, you know how to apply the product rule. It is u ddx of v plus v ddx of u. Okay. And now if I need to integrate both the sides, right? So integral and d by dx will get cancelled and I'll just get uv this side, and this will become your integral of u dv by dx times dx plus integral of v du by dx times dx. Okay, now bring it to one side and take this to this side. Okay, so we get integral u dv by dx times dx equal to uv minus integral v du by dx times dx, right? So let u is fx and dv by dx is gx. So what is du by dx? It becomes f dash x and v becomes your integral of, means take integral both sides. So v is integral of gx dx. So therefore this expression 1 can be written as your product of two function integration fx into gx dx, and which can be written as first function fx into integral of second gx minus integral of your gx dx into derivative of your first, that is f dash x dx. Okay, so this is what we mean by integration by parts, right? That is, the integral of product of two function is equal to first function into integral of second minus integral of differential coefficient of first into integral of second function. Integrals of the type e raised to power x fx plus f dash x. Here we need to break this integral as e raised to power x fx dx plus e raised to power x f dash x dx, right? Now the first one is taken as integral I1 and the second one is taken as it is. Okay, we will apply integration by parts to this first one I1 and the second one will be taken as it is. So let us apply to integration by parts to it. It will become your first function is your fx and the integral of second is ex. Now the derivative of fx is f dash x and it is ex dx plus c. Now put back the values in I. You'll get it becomes here e raised to power x fx minus integral e raised to power x f dash x plus e raised to power x f dash x dx plus c. And generally you will find this second integral which we didn't integrate it will be cancelled by the second integral that we will obtain by integrating by parts to this I1. Okay, and we will just left with your e raised to power x fx plus c. So a new formula is generated that e raised to power x fx plus f dash x is equal to e raised to power x fx plus c, right? So if you are able to represent a function or view a function which is in this form, so after writing this formula you can directly write the answer. Okay, so see example number 22, e raised to power x tan inverse x plus 1 upon 1 plus x square. So you know my function is tan inverse x and its derivative is 1 upon 1 plus x square. So it is of this form and generally the integral is your e raised to power x fx plus c. So who is fx here? E raised to power x tan inverse x plus c. So let us start with exercise 7.6 and the first question is x sin x. Okay, so algebraic ILATE rule is applied here. So first thing is of your inverse trigonometric function, then logarithmic, then algebraic, then trigonometric, and then exponential. So algebraic is taken as first and trigonometric as second. Okay, so let us start. First function integral of second minus integral ddx of first into integral of second times dx. This complete term that you will obtain after solving is to be integrated one more time. Okay, so let us apply first function x integral of sin x minus ddx of x into integral of sin x dx. Okay, integral of sin is minus cos minus ddx of x is 1. This is minus cos x. Okay, so it becomes your plus cos x minus x cos x plus cos x. Integral of cos x is sin x, right? So minus x cos x plus sin x plus c is the answer. In x sin 3x, first function is 1 is your x and sin 3x is your second function. So a product rule is it will give you x integral sine 3x minus d dx of x and integral sine 3x. So integral of sine 3x is minus cos 3x by 3. Okay, so here you will obtain your plus, take this negative sign outside, it is cos 3x 1 by 3 outside, right? And this term is same as it is, so cos 3x will give you sine 3x by 3. Okay, so just arrange the terms and this is the required answer. X square e raised to power x, first function is x square. Okay, exponential is the second one. So the rule will be applied as first function x square integral of ex integral d dx of x square into integral of ex. Okay, so it gives you x square ex and it gives you 2x e raised to power x, right? So take 2 outside and this is x ex now. So again we need to apply the product rule. So product rule will be applied here. Okay, and after opening and solving you will get this as the answer. X log x, so log x will be taken as the first function. Okay, so log x integral of x minus integral d dx of log x into integral of x dx, right? So it is log x square by 2 minus this d dx of log x is 1 by x into x square by 2. So 1x gets cancelled and we'll get it as minus half integral x, which is your x square by 2, and rest term is same. So the answer is x square by 2 log x minus x square by 4 plus c. For x log 2x is first. Okay, so and x is your second. So log 2x integral x, which is your x square by 2 minus d dx of log 2x is 1 by 2x into 2 and it is x square by 2, right? So see what can be cancelled, this 2 will be cancelled with this, your x will be cancelled with it. So we'll get just half dx. Okay, so here the first term is same as it is and it is half x dx, it is x square by 2. So just arrange to get this answer. And sixth one is x square log x, again log x is first, this is second. So log x square will give you x cube by 3 minus 1 by x into x cube by 3. Okay, 1x gets cancelled, so I'll get 1 by 3 x square will give you x cube by 3 and this is the required answer. X sine inverse x, so you can do this question either directly by this also, but the better suggested way is put x as sine theta, so that dx is cos theta d theta. So question changes to your sine theta and it is theta into cos theta d theta. So it becomes as half. This can be taken by multiplying and divided by your this 2. We'll change it this function as theta sine to theta. Half is outside and this becomes your sine to theta is 2 sine theta cos theta. Okay, so now you can integrate by taking theta as first and second as sine to theta. So it is theta minus cos to theta by 2, the integral of this, and d theta of theta is 1 and this is minus cos to theta by 2 d theta. Now open it up, right? Now you have to put back the values of theta. So theta is your it is your sine inverse x. Okay, so it becomes your minus sine inverse x, so it becomes 1 minus 2x square. Okay, plus this is sine theta into cos theta is your, you can write it as root 1 minus sine square theta. Okay, because you have to express the answer in terms of x now. Okay, so open up and you'll get this desired answer, right? See the formulas used. X tan inverse x is again, tan inverse x is your first function, x square by 2 integral of x minus integral d dx of tan inverse x is 1 upon 1 plus x square into x square by 2 dx. Okay, so the first term is same, it is half x square upon 1 plus x square. So the best way to solve such questions, you must remember, is add and subtract minus 1. Break the numerator, 1 plus x square upon 1 plus x square is 1 and it is minus 1 upon 1 plus x square. So it becomes 1 minus 1 upon 1 plus x square. So integral of 1 is x and the integral of this is tan inverse x. Okay, now multiply by half and this is the required answer. For x cos inverse x, again you can put cos inverse x as theta, x is cos theta. So dx is minus sine theta d theta. So this question changes to again in that form which we did right now, minus half and this is theta sine to theta, which can be carried out as it is. And don't forget to put back this your theta as cos inverse x and change the complete result in the terms of your x. Sine inverse x whole square. So here you put x as sine theta, so that dx is cos theta d theta, right? So this becomes your theta square cos theta, right? So you can integrate by parts now. Theta square, integral of cos is sine minus integral of this derivative of theta square is 2 theta and this integral is your sine theta. Now again you have to use integrate by parts, take 2 outside. So it is your theta and integral of sine is minus cos minus d theta of theta is 1 into minus cos theta. Okay, So open it up. Right now again we need to put back the values of theta, right? So your theta from here is sine inverse x, okay, sine inverse x square, and sine theta is your x, right? And cos theta will be changed as root 1 minus sine square theta, which is root 1 minus x square, okay? So this is the desired solution after changing it. Number 11 is x cos inverse x upon root 1 minus x square. So again put a cos inverse x as theta, x is cos theta, dx is minus sine theta d theta. The question changes to, again you can see it can change to sine theta will get cancelled after changing, and it is just theta cos theta. So by parts you will integrate. Just be careful with this negative sign, take it outside. So theta integral of cos is sine minus d theta of theta is 1, and then sine theta d theta. Again open it up, right? So again integral of sine is your minus cos, remember minus cos. So it is minus theta, change sine theta to cos as we have substituted cos as in terms of theta. So it is 1 minus cos square theta minus cos theta plus c. Now change theta as cos inverse x and cos theta as x. So you will get this desired answer. Okay, be careful with the negative sign. X secant square x, so x is your first function, secant square is second, so it is x secant square integral is tan minus d dx of x is 1, secant square is tan integral is minus log mod cos x. So this is the required answer. To integrate tan inverse x or sine inverse x or cos inverse x whatsoever alone, you need to take 1 as the other function. So tan inverse x into 1. So this is my first function and this is second. Okay. So tan inverse x into integral of 1 is x minus integral d dx of this is 1 upon 1 plus x square into x, right? So again how to integrate now this, you have to, means you should know that we can put this 1 plus x square as t. So this becomes your dt by t type of graph, or you can multiply and divide by 2, because you can view that the derivative of 1 plus x square is 2x, which can be made in the numerator by multiplying and divide by 2, and then you can directly use integral f dash x upon fx is log mod fx. Okay, so in that way it is half log mod 1 plus x square plus c, and the first term is c, which is the required answer. X log x whole square, again log x square is first, x is second, so it becomes log x square, integral of x is x square by 2 minus derivative of this is 2 log x, okay, 2 log x into d dx of log x is again 1 by x, and it is x square by 2. So it gets cancelled, and we will get from here again your x square by 2 log x square minus it is again x log x. So again you will apply your integration by part to the second term, and we can just get the answer. X square plus 1 log x, again log x is the first always, and into x square plus 1. So log x into the integral of this is x cube by 3 plus x minus d dx of this is 1 by x into x cube by 3 plus x. Okay, solve the terms, take things common, and 1 x will be cancelled from here. It is x square by 3 plus 1, which can be integrated alone, taking aloof. Minus 1 by 3 integral x square is x cube by 3, and it is minus your x plus c. Okay, and the first term is same as it is. Here it is e raised to power x sin x plus cos x. You can view that it is of this form, e raised to power x fx plus f dash x. So fx here is sin x, f dash x is cos x. So using this formula, please write the formula. If you are using it directly, then it is e raised to power x, fx means sin x plus c. In number 17, you have to do a bit, means you can see that e raised to power x is at the top. Now this question cannot be carried out whatever we have learned till now, all the substitution method or the formula method. So you can view that there is e raised to power x, and this numerator can be made as denominator by splitting it as adding and subtracting 1. Okay, and take ex apart, and then separate the numerators as we are doing, right? So x plus 1 upon 1 plus x plus 1 whole square will be 1 upon x plus 1, and this is your minus 1 upon x plus 1 whole square. Now this is my fx, and see the derivative of x plus 1 raised to power minus 1 is minus 1 upon x plus 1 raised to power minus 2, which can be written as minus 1 upon x plus 1 whole square. So it is fx plus f dash x. So write this formula, and who is fx here? This is all explanation of what is the derivative. Okay, so it is e raised to power x, fx here is, fx is your 1 upon x plus 1 plus c. Number 18 is e raised to power x 1 plus sin x upon 1 plus cos x. Now break the numerator, right? Because you need to just express it in the form of fx plus f dash x. So it can be written as 1 plus, this can be written as sin x is 2 sin x by 2 cos x by 2, and denominator is 2 cos square x by 2. Now break 1 upon 2 cos square x by 2 is your half. See, this thing is written here, okay? Don't get confused. It is half secant square x by 2. And this means if I'll break it, you will find 1 cos will get cancelled with it, 2 will get cancelled, and I'll just get it as tan x by 2. Now, the derivative of tan x by 2 is your half secant square x by 2. So, my fx is tan x by 2. This is the derivative. So, the answer is raised to power x tan x by 2 plus c. Now, this question is again of that form. Now, here fx is clearly your 1 by x and derivative is minus 1 upon x square. So, the answer is e raised to power x fx, that is e raised to power x by x plus c. Again, this question is again in this format. So, I need to just make the numerator as denominator. So, there is no need to add subtract, but just I can bifurcate minus 3 as minus 1 minus 2. So, minus 1 x minus 1 upon x minus 1 whole cube will give you 1 upon x minus 1 whole square, and it is minus 2 upon x minus 1 whole cube. Now you can generate that if this is fx, then derivative is, you can see, minus 2. So minus 2 x minus 1 raised to power minus 3, it is minus 2 upon x minus 1 whole cube. So this is my f dash x, right? And using this formula, please mention the formula whenever you are using it. The answer is your e raised to power x fx. Who is fx now? 1 upon x minus 1 whole square plus c. Okay. Now, how to evaluate your e raised to power ax sin bx type of result or e raised to power x cos bx type of result. Now, in these questions, no doubt exponential is at last, but it is better you take your e raised to power x as first function and your sine or cos, whatever is there, that's the second function. And here you need to use this integration by parts twice. And once you will integrate it, you will again find that this the original question function is made again. So you'll replace it as I2, right? So see, question number 21 is there, your e raised to power 2x sin x. So see from here, see carefully, I have taken, instead of sin x, I have taken your first function as e raised to power 2x. So let us apply rule as e raised to power 2x into your integral of sin is minus cos minus ddx of e raised to power 2x is 2 e raised to power 2x and integral of sin x is minus cos x. Okay, now minus, say this is I is there, minus e raised to power 2x cos x plus, take this minus sign outside, so plus 2 e raised to power 2x cos x. Okay, again I have to apply the product rule, right? So here, so this term is same, plus 2 times e raised to power 2x, integral of cos is sine minus integral ddx of this is 2e2x and integral of cos is sine. Okay, right? Now again open the terms and it is minus 4. So this is 2e2x sin x and this is minus 4 e raised to power 2x sin x. Now you will find that this question will be your I again. Here when you will integrate use by parts twice, you will again find that the original question is made. So I'll rename it as I. So it becomes minus 4i. Take this minus 4i to other side because 5i will become your, you can take e raised to power 2x common from these. So it is 2 sin x, okay, minus cos x. Just to keep rearrange the terms to keep this negative sign in the middle instead of with the first term. So I is your divide by 5 all sides. So e raised to power 2x by 5, 2 sin x minus cos x plus c. Okay. So this question can also be done by taking sin x as first and e2x as second function. But in general, it is suggested that you should, if it is of this form, you should try to take e raised to power ax or 2x as the first function. Okay. Sin inverse 2x upon 1 plus x square, you know, you're very well familiar with this question. Here you need to put x as tan theta because I need to eliminate this sin inverse. Okay, so dx is secant square theta, so this becomes your sin inverse 2 tan theta upon 1 plus tan square theta secant square theta. So this is the formula for sin 2 theta and we get just 2 theta secant square theta. Take 2 outside, theta secant square theta, apply product rule, theta integral of secant square is tan theta minus, this is dd theta of theta is 1, secant square integral is tan theta equal to 2. This becomes theta tan theta minus, this is tan theta. What is the integral of tan theta? It is your minus log mod. You can take minus log mod cos x can also be taken, right? So here minus log mod secant x. It is not actually minus is because of this sign. Actually integral of tan is either minus log mod cos or it is log mod secant. So log mod secant is taken here. Now I think for the purpose of as the secant can be easily converted to tan by the formula root 1 plus tan square, so it is root 1 plus x square. That's why secant theta is taken here. So because you know that I have to replace the values of theta, so theta will be tan inverse x and x will be tan theta. So replace all the values. Okay, so this becomes tan theta is your x and theta is tan inverse x. Here it is log of secant theta is changed to tan form 1 plus x square, and 2x tan inverse x minus log 1 plus x square plus c is the required. Now choose the correct option. Here a little bit of substitution is required, as this question is not that simple, means it is not where you should go for directly for integration by parts. So better to put x cube as t, so that 3x square dx is dt. Okay, so question changes to I is equal to 1 by 3 times e raised to power t dt. Okay, so it becomes 1 by 3 e raised to power t plus c. So generally sometimes the question can be means reduced to simpler form if we it's no doubt in given in this exercise, but there is no need. You found that when I substituted we felt no need of integrating it by parts. Okay, so that will be just wastage of time if we are working out on that. So better is to go for substitution, and in that way the question will be simple, and the answer is 1 by 3 e raised to power x cube plus c. Okay, number 24 is again take the secant x inside. It becomes e raised to power x secant x plus secant x tan x. You know the derivative of secant x is secant x tan x. So this is my fx is secant x, f dash x is secant x tan x. So it is e raised to power x fx plus c. So who is fx here? You write this formula. Okay, it is e raised to power x secant x plus c. Okay, so option number B is correct. Okay, here it was also option number B is. So this was all regarding your exercise of integration by parts. So this is a very important concept where the product of functions is to be integrated, right, which do not reduce to a single term, right, or single function. So there we use the integration by parts method, and a very important formula has been generated here, that is your e raised to power x fx plus f dash x, right. That result is suitable where this form is there, and you can directly apply the formula, but please mention the formula alongside, right. And then the inverse trigonometric functions that we did how by substitution, like they can be reduced to your integration by parts form. And the very important one, that e raised to power ax into sine bx ax, something like that function. Here it is generally suggested as per, you can take any one of them as first or second, but it is generally suggested that better go for e as e raised to power ax as your first and sine as second, right. And there you find that after 2 times when you apply integration by parts, your function will become again. So you'll put that step as I and arrange all the i's together, okay, so that we can integrate that function. So I hope whatever is taught is clear to you. Practice it well. Thank you very much.